All right, this is the lesson on solving and graphing inequalities. So it's basically taking what we've done with equations and applying it now to inequalities. So what is the difference between solving an equation and solving an inequality? Equations only have one solution. You see x equals a certain number, y equals a particular number. It's not more than one number, there's only one answer. But inequalities have infinite solutions. The solution set is shown on a number line. And we practiced graphing those, remember, on the prior knowledge. You solve inequalities using inverse operations just like you did with equations. So there's really not much difference in solving them. It's representing them that's going to be different. How do I graph my inequalities? So again, reminder, because we did talk about this already. First, you need to know if you should draw an open circle or a closed circle on the solution. We leave it open if the sign is greater than or less than. We make it closed or filled in if the sign is greater than or equal to or less than or equal to. Then plug in an answer to determine which way to draw your line. So let's try some examples, and we're just doing very basic one-step inequalities here. So I'm going to drop my line from the inequality sign, and I'm going to say, okay, x plus 2 or positive 2, and the opposite of a positive 2 is a negative 2. So just like with the equations, I'm going to do the same thing. Okay, so I get x is greater than or equal to, my signs are the same, so I'm going to add them and keep their sign. So I get x is greater than or equal to negative 12. So remember, I put negative 12 in the middle. Then I'm going to pick a number that's larger. And remember, because it's negative, I'm counting down, so negative 11. And then I'm going to pick a number that's smaller. So I'm going to pick negative 13. I look at my sign. It's greater than or equal to, and it says up here that we're going to make it closed or filled in if it's greater than or equal to. So I'm going to have a filled in dot. And then I'm going to look. And remember, there's two ways I can do it. I could plug a number in, so I'm going to plug in negative 13. Is negative 13 greater than or equal to negative 12? No, it's not. So I don't want to shade this way. I'm going to want to shade in the opposite direction. Remember, another way we said that is when we look at this arrow, it's pointing in that direction. That point is already in that direction. So when your variable, only when your variable is first, does that work? Okay, so let's try it here. 8 is less than negative 5 plus p. Drop my line from the inequality sign. I see a negative 5, so I'm going to add 5. I need a positive 5 to make that go away. Okay, so those cancel out, leaving me p. Keep my sign, and 8 plus 5 is 13. So I know 13 is less than p. If I don't like it like this, I can flip my p and 13. Like some people really like to have their variables first. So it's okay to change them, but if you're going to flip those around, you also need to flip your sign around. Okay, it still needs to say that p is greater than 13. So go over here. I'm going to put 13. A number larger is 14. A number smaller is 12. I'm going to look, it's just the less than sign, not or equal to, so I'm going to have an open circle on the number 13, meaning we don't want to include it. 13 is not less than 13. That doesn't make sense. And then I'm going to graph it. Now, be careful here. If you chose not to rewrite it like this, and you just left it like this, my variable doesn't come first here. So that arrow trick is not going to work. You would definitely have to plug in a number. So if I plugged in 12, 13 is less than 12. No, that doesn't make sense. I don't want to shade in that direction. I want to shade in this direction. Now, if you did change your numbers around, and this is why some people do, so now the variable's first, now my arrow is pointing in this direction. Okay, so then yes, I know that's the way I'm supposed to shade. So there is a benefit with putting your p first. All right, 9 plus y is greater than 12. So I'm going to drop my line from the inequality sign. This is a positive 9, and I need to get rid of that positive 9, and I can only do that by getting a negative 9 to go with it. Because that will cancel each other out, leaving me y is greater than 3. I'm going to put 3 in the middle. A number larger is 4. A number smaller is 2. It's a greater than sign, not or equal to, so I need an open circle on the number 3. My variable is first, so I can use the arrow trick. The arrow is going in this direction, so that's the way that I want my graph to go. Or again, I could plug in a number. If I plugged in 2, 2 is greater than 3. Does that make sense? No, 2 is not greater than 3, so I do not want to shade in that direction. Okay, one more. Negative 14 is less than or equal to k minus 8. So again, I'm going to drop my line from the inequality sign. I need to get the k by itself, and I see it with a minus 8 or a negative 8. And the opposite of a negative 8 is a positive 8. So when I put that positive 8 there, they're going to vanish, leaving me k. Keep my sign. A negative and a positive, my signs are different. So I'm going to subtract my numbers and keep the sign of the larger number. So I've come up with negative 6 is less than or equal to k. If it were me, though, I would switch everything around so that my k is first, because that'll help me when I graph. Okay, so here I have negative 6. So a number larger is negative 5. A number smaller is negative 7. So, yeah. Okay, now, greater than or equal to. That or equal to lets me know it's a filled in dot. Okay, and now that I've switched it so that my k is first, I can use that arrow trick. My arrow is pointing in that direction, so that's the direction I want to shade. Again, if I don't flip this, I can't use that arrow trick. It doesn't work. Look, it's pointing in the wrong direction. So then I would have to plug in a number. Let's say I plugged in negative 7 here. Negative 6 is less than or equal to negative 7. No, that's incorrect. I don't want to shade in that direction. Okay, let's look at the back. Whoa, watch for those negatives. So those negatives are a little bit tricky because it changes something. When solving inequalities, if you multiply or divide by a negative number, you must flip your sign. Okay, so if you're going to multiply or divide by a negative, then you have to flip your sign. So let's try a couple of these examples. I see x divided by 7 is greater than 6. I'm going to drop my line from the inequality sign. I know the opposite of division is multiplication, so I'm going to multiply by 7. Okay, these would cancel out, so I would be left with x over 1, which is just x. If I multiplied by 7 on that side, I definitely need to do the same thing on this side. Now, I'm multiplying by a positive 7. So since I multiplied by a positive 7, my sign gets to stay the same. It's x is greater than 42. All right, so 42. A number larger is 43. A number smaller is 41. I see greater than, which means an open circle on 42. And then the variable is first, so it's pointing in this direction. It's telling me to shade to the right. Or plug in a number. 41 is greater than 42. Nope, that doesn't make sense, so I don't want to shade in that way. Okay, negative 5n is less than 25. I drop my line from the inequality sign. A number next to a variable means multiply. Don't add 5 here. That's the mistake lots of us were making. These are negative 5 times n, and the opposite is division. So I'm going to divide by negative 5. Uh-oh, wait, what did I say? I said I'm going to divide by a negative? But that's this, whoa, when I divide by a negative, I need to flip my sign. So it's no longer going to be the less than sign. It's now going to be the greater than sign. So 25 divided by 5 is 5, and a positive divided by a negative is a negative. So now I have n is greater than negative 5. All right, so let's put negative 5 in here. A number small or larger is negative 4. A number smaller is negative 6. It's just a greater than sign, so I'm going to have an open circle. And my variable is first, so that's good. I can use the direction of my sign to know which way to shade. So I know any number that is larger than negative 5 is going to work. Or again, you could plug in a number. Let's plug in negative 4 this time. Is negative 4 greater than negative 5? Yes, that's a true statement, so I know I need to shade that way. Okay, 2 more. 33 is greater than or equal to negative 3k. All right, so I'm going to drop my line from the inequality sign. See a negative 3 times k. That's what this is saying. So the opposite of multiplication I know is division. So I'm going to divide both sides by a negative 3. Wait, what did I say? I said I'm dividing by a negative? Remember, when I divide by a negative, I have to switch my sign. So I'm going to flip it around. 33 divided by 3 is 11. And a positive divided by a negative is a negative. So I know negative 11 is less than or equal to k. Well, here's the thing. I want my variable first. And if I want my variable first, then guess what I have to do? I have to switch that sign again. Kind of crazy. Okay, remember, you don't have to do this step. You can leave it just like that. That's fine. Okay, so I'm going to put in my negative 11. A number bigger is negative 10. A number smaller is negative 12. It says less than, or down here, it says greater than or equal to. So because it says or equal to, I'm going to fill that circle in. Now I'm going to use this one right here because I like it when the variable's first because it points in the direction that I want to shade. So I know I need to shade anything to the right of negative 11. Anything to the right, including the number 11, would make this statement true. Negative 11 is greater than or equal to negative 11. They're equal, so that works. Okay? Negative 10 is greater than negative 11. Negative 12 is greater than negative 11. No, that doesn't work. Okay, one last time. Negative 11 is less than or equal to 1/2 x. All right, I'm going to drop my line from the inequality sign. Again, these are next to each other. 1/2 is next to x. And when they're next to each other, that means multiplication, which means I need to divide both sides by 1/2. Any number divided by itself is 1. I divided by a positive, so I'm going to leave my sign the way it is. And then I'm going to do negative 11 divided by 1/2. Okay, negative 11 divided by 1/2. Keep, change, flip. So really it's negative 11 times 2, which is negative 22. Okay, so I want to clarify something. I know there's a negative in my division problem, but I'm not dividing by a negative. It is negative 11 divided by a positive 1/2. Just because there's a negative in the division problem does not mean I flip the sign. Same thing with multiplication. It's if when I move that half over, if that half was negative, that's when I flip my sign, and that can be confusing. Okay, I don't like this because I want my x first, so I'm going to change everything around so that my x is first. Man, I like graphing to the right today. All right, so I'm going to say negative 22 in the middle. A number larger is negative 21. A number smaller is negative 23. It says greater than or equal to, so that's a filled in dot. And again, my arrow is pointing to the right. I think it's pointed to the right all day. That's not always the case. So I'm going to shade to the right. All right, so now what I want you to try is I want you to see if you can figure out the answers to these 6 problems on your own. See if you can figure them out. And that's it. I will see you when you come back to school.